name is Nicholas Ditto. I'm the honors chemistry teacher at Speer Academy. I hope you enjoyed the lesson and found it helpful today.
Good morning. Please grab the two handouts. Please grab the two handouts. Good morning. All right, good morning, guys and girls.
Good morning, Mr. Ditto.
So, this morning you're going to have the next 8 minutes to work on your do now. There is a backside that has a few questions on it. During this 8 minutes, should be silent and independent. I will come by and check in your homework. So make sure that you have it out. Put the timer on the board. You all may get started. Alondra.
Here.
Ray.
Here.
Oli.
Here.
Victoria.
Here.
Gabriella.
Here.
Roberto.
Here.
Saul.
Here.
William.
Here.
Sophia.
Here.
Alyssa.
Here.
Adrian. Omar.
Here.
Christina.
Here.
Ryan.
Here.
Larissa.
Here.
Cassandra.
Here.
Melissa.
Here.
Christian.
Here.
Brandon.
Here.
Ryan.
Here.
Emmanuel.
Here.
Jennifer.
Here.
Stephanie.
Here.
Richie.
Here.
Michael.
Here.
Abigail.
Here.
Alyssa.
Here.
Osvaldo. Jesus.
Here.
Cindy. Destiny. Andrew.
Here.
About 30 more seconds or so. If you've not gotten to the back, make sure you flip over to the back side. Sentence, and then get your eyes back up front. As you finish up that sentence, make sure you get your eyes back to the front. Great. Here's what I'm going to have you do. You're going to take the next 3 minutes or so, go over the answers on the front side with your group of 4. Make sure that you are reaching agreement and explaining how you got your answer if you got different ones. Then go to the back side, review those couple, and I'll call around when we're done. About 3 or 4 minutes, level 2, spin around and you may get started.
The blood levels aren't changed by the same. The time has changed, which affects them all.
So I would say, the way to think about it is, if I only took it away with just like a person and the levels, I wouldn't be able to say what's being changed. That would be a difficult experiment. But if I took one of the people away, I could still run this experiment and see like how this time affects the blood. So I'd say that's the way. Because it is tough. There are 2 people that didn't change. That's one that it's like, it's consistent. So why not the person? Why do you think time so it looks like it's deliberately changed. Yeah, that's good. Spin yourselves around so you can again see the front. Hey, we're going to review a a couple of these, starting with number 1. What was our independent variable in this experiment? What was the participation?
It was time because it was increased by the scientists, and that's what affected the leader of the
So it's purposely being changed. It's what's affecting how much sugar is in their blood. What would the dependent be? What were they specifically measuring in this experiment? What?
The blood level.
Yeah. So we're looking at blood level, how much sugar is in the blood. Go ahead, flip over your paper to the back side. Which one of our particles is positive? Protons, you got it. And then which one would be our negative particle? Electrons. So we have a positive and negative. What would we expect with these two? Would we expect they attract or repel each other? Okay, why so?
They're opposites.
Opposites, yeah, sure. Opposites attract. You got it. So that's going to lead us into what we're doing today. We're going to investigate what things affect that attraction. Because you're right, protons, electrons are attracted. What things affect that? Does it matter the distance? Does it matter if we have 5 protons or 1 proton? Does it matter if we have 8 electrons? What are these things that might affect that? So what I need you to do is take the next 30 seconds or so, put away your do now, and update your table of contents that will be up on the board. Table of contents updated for today. And the only thing that you will need out will be today's handout, and you'll need your periodic table for one portion. So most people are finishing getting a copy down. Make sure that we have out today's handout and a periodic table. That colorful one will be really helpful for today. So our big question for today is what factors, what things affect the attraction between protons and electrons, or the nucleus and the electrons. So by the end of today, we should be able to pull out 2 different factors that affect it and have an idea why that is, okay? This is really going to help us better understand a lot of the trends that we'll investigate next class. Why are some of these patterns that we figured out already, why are they patterns? Has a lot to do with this idea of protons and electrons being attracted to each other. At each of your tables, I have dropped off your 4 roll cards for today. You will have the next minute or so to decide who is in what role. Don't keep the same roles as last time, so make sure you rotate them and refresh yourself on what your job is today. You have the next minute or so with your group. Decide roles. Make sure you know your job. All right, go ahead and wrap that up in 3. Your back is to the front. Spin yourselves back around in 2. Come back together. Spokespeople, please raise your hand if you are a spokesperson today. Let's see, Michael, what's your job today?
We have to communicate questions and we have to ask you the questions and talk with us.
Yeah, you got it. So if your group's having a hard time, you're the one that's going to ask me the questions. If you are the quality control, raise your hand. If you are your group's quality control, raise your hand. Alondra, what is your job today? Got it. Make sure we're agreeing before we're writing down and moving on. If you're a facilitator, raise your hand, please, if you are a facilitator in your group. Christina, what is your job today?
Keep the group moving forward, make sure everyone's on task.
Yeah, you got it. Stay on task, keep moving forward. And process analyst, last but not least, raise your hands, please, if you are a process analyst. There should be somebody in this back group as well. Oh, I see you. Go for it. What's your job today?
Making sure the group, everyone in the group is participating.
Got it. Make sure everyone participates, working together well. If you open up your activity for today, if you open up to the first page, you will see a stop sign at the bottom. You will see a stop sign at the bottom of page 1. You and your group are going to have 6 minutes to get to that stop sign. If your group finishes early, have your spokesperson call me over so that I can move you along. Needs to stay level 2 and on task, so when I come by, I shouldn't hear about your weekend.
should hear about how you're working through Model 1. Okay? 6 minutes are yours. Go ahead and spin around and get started.
As distance increases, the one before.
If the distance between particles is greater, then the force of attraction becomes less. Oh yeah, no. So it decreases. Okay.
If the distance increases, force of attraction.
Oh yeah.
I think that's like a reasonable claim. I think that's a reasonable claim. Again, this you're just trying to make a prediction, so that thinking makes sense to me. I'm not sure that
Oh, less than
So that just means a small number. So it doesn't mean it's a negative number. It's just a small number. So I would say for this, you don't have to calculate out the exact one, but based on the trend, do you think it's going to be greater or less than? So it's 50 nanometers here. Tell me why you're going to give us.
Two protons. No, it would be greater. These are two protons. Yes, then it would be two protons and electron.
You're on the outer ring. The outer ring is electron. Not the question. This right here. You wrote
That's
proton,
what yeah.
but you're pointing to the electrons.
Because it's the same number. If it's 3, there's 3
But they're two different subatomic particles.
If there's
Because they're distance equal. So it's pulling on each side. You all were saying the same thing, but perhaps looking at it as a view.
Take a quick pause in your group, so you need to get your voices back on. If your back is facing the front, spin yourselves back around in 3, back in 2, back in 1. Okay. I know most groups are on Model 2 right now. Please flip the page back to Model 1 for a second. Flip it back to Model 1. So what is our independent variable in this Model 1 and the y? Because we're changing two things. Stephanie? Okay, and why is it the distance?
It's changing on purpose.
Okay. Changing on purpose, we're on the right track. Why might it be changing on purpose? Or how do we know that one's being changed? There's no passage to tell us. Right?
Oh, that's what you're changing.
Say it again?
It's what you're changing.
Ah, but how do you know that's what we're changing and not the force of attraction?
Oh, because the diagram says it, because it goes from point 10 to point 20 to point 30.
Ah, so it seems like it's on purpose. Those are specific numbers. What about the force of attraction? Is it like specific numbers, or does it look a little more random?
That's more random, because we have 58 and 26.
Yeah, so we're jumping around. Yep. So you're right. Distance is the one on purpose. Sometimes you need to think a little bit about like, hey, is it being changed on purpose? How do we know? You won't always get a passage. I need a sentence. How can we explain that relationship between our distance and force of attraction? Omar, go ahead.
So as the distance increases, the force of attraction decreases.
All right. Give me a thumbs up if you agree with Omar's statement. Thumbs down if you got something different. Got it. So there's that inverse relationship. They're sort of opposites to each other. To Model 2. Take a sec, flip it over to Model 2. As you are moving down the group, so down the column, up and down, what's happening to the size of our atoms, the physical size of them? What's happening as you are moving down to the size? Go ahead. What's happening as we move down?
Moving down, I think that the attraction gets stronger. I mean, weaker.
Okay, but hold up. Don't jump ahead yet. As we're moving down, what's happening to the size? Just the physical size of our atoms.
They're getting bigger.
Oh, they're getting bigger and bigger as we're moving down. Okay. So, how is that distance changing? If we look at the outermost atom, that little valence electron on the outside, how is that distance changing as we're moving down our group? Imanol, how is that distance changing? So, based on Model 1, what would we predict about that force of attraction? Imanol said it's getting, the distance is getting bigger and bigger. What do we predict about that force of attraction? Getting weaker because it's getting pulled further apart from the nucleus. You got it. You all, almost everyone, is on Model 3. If you're not quite there, that's fine. Make sure to pull me over when you get there. About 6 to 8 minutes to get through Model 3. Make sure you hit the stop sign. Stop at the stop sign. And go ahead and get started.
As the number of protons increases, the force of attraction increases. Actually, I think the question is to think that you're one of yeah, so
Where are you set? So do you mean like, do you think the two electrons are gonna push each other? So what do you Okay. So you're thinking that if we add another electron on the other side, it'll just balance out where there's no force at all? Okay. So then why do you think that would be?
the force of attraction is neutral. So the outermost attraction will increase.
So I would say right here, let's find the one that has.
Also, with like total force of attraction, like I don't really it's not yeah, you divide like the whole. No, yeah. So this would be like the total amount. So this would be 3,
If your back is facing the front, spin yourselves back around. We should be back facing the front at a level 0. If you are a spokesperson, please raise your hand. If you are a spokesperson for your group, raise your hand. Here's what we are going to do. When I say go, spokespeople are going to go to another group. Hold up. You are going to bring with you your polo, your activity. You are going to check your Model 3 with your new group. Did your group get the same thing, or were you getting very, very different answers? So check your Model 3. When you're done, you're going to return back to your original group. So this should take about 3-4 minutes to go to a new group, check, and return. You may go ahead and swap. Only person moving is spokespeople. This person needs somebody.
Yeah, it was easy because in this electrons, if you go back to and then each electron is the same pool that the light valve, they get the same pool of the 3.
Yeah, but it's talking about just the electrons, it's not about the proton.
Right, yeah, the electrons go 6.9 in the C3 here, and there's 3 here, right, and then that's 6.90 for 3, and even though there's just one, still 6.90, and up here, it says that they all get the same force, because it's not divided up, so each of them hold the same weight.
Yeah, it's just all right. Yeah, okay, because it's only attracted by this one. These two are just there, so really, yeah.
Oh,
I get
it's because all the arrows are pointing to the bottom one, so the other one is just the one.
Yeah, see, this one's pointing to the bottom. I understand.
You all check your Model 3? Take about 30 more seconds. Finish checking all those answers. And return to your group. Sit back to your group. Alright, get your voices off. You don't have to spin around, just get your voices off for a quick sec. Okay. At this point, everybody should have checked in Model 3 and you should be back with your original group. You'll have about 6 to 8 minutes to finish that final model. Model 4, we'll check in together and then let you pull together some of those key ideas with your group. So about 6 to 8 minutes to finish Model 4. If you are done early, call me over so I can move you along. Okay, go ahead and get started. Timer's on the board. Finish Model 4, please take a quick sec, turn to Model 3. So turn to Model 3 so you'll have that in front of you. So Model 1 and 2, you talked to me about the distance and that force of attraction, that being a relationship. What was the relationship in Model 3 between the number of protons and that attractive force? So what was the relationship there on Model number 3? Let's see, Melissa, what did your group get for that relationship? Right, so there's that direct relationship. More protons, stronger force. As you look on that second page of Model 3, does it matter how many electrons are there? If I add 5 or 6, does it matter? Is the charge split apart? Or does each one get that full force? What happens if I add more electrons? Does that matter too much? Adrian, what did you talk about with your group for this one? Doesn't change anything, you got it. So no matter how many electrons, they're getting that full force. You got it. So, please go ahead and flip to Model 4. We'll clear up some of the key concepts on that. Moved across our row from sodium to aluminum to chlorine. Did that distance between the valence electron and the nucleus change? Christina, you're shaking your head now. Why? Yeah, good. They all, way to refer back. They all have 3 energy levels, so it's about that same distance. But I noticed that chlorine is pulling in that electron way stronger. Why might that be? If it's not the distance, we eliminated that. What's different? Why is chlorine pulling that one so strongly? William, what did you talk about with your group for this one?
You said because there's more valence electrons? Oh no, there's more protons, sorry.
Oh, it's fine. So, yeah, they have more protons. So what might that have to do with it? Just because it has more protons, it also has more electrons. Why does protons matter?
Because the more protons it makes the force stronger.
So the more protons, that force is going to be stronger. Good, you got it. So what I'm going to have you do with your group, you're going to have the next 7 to 8 minutes. You have 2 jobs. One is to complete your group evaluation on the front. How well did you do together? Be honest, it's not for a grade. So if you tell me 100%, and I'm pretty sure nobody was 100%, you weren't perfect. So again, you can be close, you can be close to 100%. And then you'll fill out that notes and synthesis as a group. Make sure you're using full sentences and really explaining it out. Because again, you're going to have to use that as we start our next lesson. Make sure you're explaining it out all the way. Okay? Next 7-8 minutes is yours as a group. guys and girls, go ahead, get your voices back off. If your back is facing the front of the room, spin yourself around so we can all see the front. On your notes and synthesis, 2 questions to highlight. So number 3, because again, those 2 big trends. So you all told me distance was one of those trends or one of those factors. So how far away that valence is from the nucleus. So if I'm looking at elements and they're in a group, an up and down row, what's the pattern or what should I look for? Is it getting stronger as I move down or is it getting weaker as I move down, that force of attraction? Take a couple seconds, think about it. If you need to look at your periodic table, look at it for a sec. Okay, and why would it be getting weaker as we go down the column?
Because as we go down the column, you're adding more energy to this. So you're farther away from the nucleus.
So we're adding more energy levels, making that valence electron get further. Good. What was our second factor? So factor number 1 was distance. What was the other factor that affects that attraction? Jennifer, go ahead. Can you say a little louder, please? Number of protons, you got it. So, instead of looking up and down, if I want to look across a period, if I want to look from left to right, what would be happening to that force of attraction if I move left to right across my periodic table? Go ahead.
The force of attraction increases
Why? I agree with you.
because the number of protons in the nucleus increases.
Yeah. So the number of those protons is increasing, making it pull in tighter and tighter. It's getting stronger. Okay? So what I'm going to have you do, take the next minute or so. You need to have out a periodic table. You may have out a calculator if you want. And you can take your notes and your synthesis, your little packet, and you can just set it to the side. Okay? So we'll have a quick little exit ticket, and then you'll start your homework. So, what you need out, periodic table, calculator if you want, something to write with. Okay? Take a quick minute, get that out. Okay, drop 30 seconds. That should be getting cleared off. So, you all are going to have the next 8 minutes or so to work on your exit ticket. It needs to be silent, independent as you're working on this. You may use your periodic table, you may use your calculator, no notes. If it asks you to explain, please give me an explanation. Don't just circle C and leave it. Again, that's not fully answering the question. When you finish this, flip it over and you may start your homework. If you've already finished it, you were blowing through today, that's awesome. You may work on something for another class, but it needs to remain silent until everybody has finished this or turned it in. Okay? As soon as you get it, you may get started. Please make sure to put your name so I know who to give credit to. Okay? Please make sure to put your name. As soon as you get it, you may get started. last couple of minutes is people finishing up their exit tickets. You finish early, just flip it over and you can start your homework for this class. If you're all done, you can work on something for another class. I'll have you turn in your exit tickets right here on your way out the door. Those 3 or 4 questions on the very last page. Since there's only a few, make sure they're answered very well. Put your exit tickets, you only go.